So today we're running through the practice test for 8.1 to 8.3, 3 little sections, and that's why it's one page, front and back. That's all it is. So when we get back to 8.1, what we have to remember is there was only one situation where it's not multiplication, where it's division. What word do we watch for to know that we have to divide? That's it. Inversely is divide. Jointly is multiplication, directly is multiplication, inversely is the word we have to watch for. So this one says, write a function that models each variation. X equals -5 when y equals 3. V varies inversely as x. So, not v, y. Y varies means I have to write y equals k because it said y varies, so we do the y piece. And then varying means we have to have a constant of variation. And then inversely tells me division. Now, do you remember what we do next? Yeah, we plug in the x and the y so we can figure out what k is. And you could slap a 1 under the 3 and cross multiply if you want to, or you could just multiply both sides by -5, however it works for you fastest and most accurate. K equals -15. Now, unfortunately, some people stop there. It didn't say write an equation and figure out what k is. It said we are supposed to write a function that models that variation. So we have to put this -15 back in here for k. That's the model for inverse variation. So don't stop when you think I've got k. You've done most of the work, but you didn't plug it back in yet. Our job is to figure out k and plug it back in. So let's take a look at number 2. X equals 3 and y equals 5 when z equals 6. So we know this is going to be combined variation. It's got more letters for us. Y varies directly, so we start the same way. Y goes first because they said y varies directly. Directly, is that multiplication or is that division? That's multiplication. Directly with x, and inversely, what do we do with that? There's our division with z. So our model so far is y equals kx over z, but we have to find k. How do we find k? Plug the rest of them in. Let me move this up so I've got some room to work and do some plugging in. Well, good news, 3 over 6 is 1/2. So we could change that to 5 equals k over 2. And then multiply both sides by 2 to get k. We're not going to stop there when we take this test on Thursday, right? What are we going to do with that? Plug it back in. So we're going to take this and we're going to put it right there. And then we'll box that up so that, hey, my answer's right there. That's what I had to do. Now, when we did the homework, there were always follow-up questions where it would say, write this and then, put x is 5 and z is 2 or something like that in there. We're not even doing that. This is just write the models. So, step 1, find k. Step 2, substitute k in. Those are our 2 little steps for our direct and inverse and joint variations that we talked about. By the way, we didn't mention joint variation up there, but is joint variation multiplication or division? Exactly. Remember, inversely is the only one where we divide. Next up, 3 and 4. This is still about direct and inverse variation. So it says, is the relationship between the values in each table a direct variation and inverse variation, or neither? Write an equation to model any direct or inverse variation. So direct variation looks like this. And inverse variation looks like this. But in those tables, do you see anything labeled k? So that means for the table part, we have to look at what's happening with x and y to figure out whether or not it's direct or inverse. So right now, my little formula here doesn't have the x's and y's together. I need the x's and y's together, so I have to divide both sides by x. And this tells me that if I take y and divide it by x, and I get the same number every time, that's because it's direct variation. And this little formula over here, if I move the x's and y's together by multiplying both sides by x, says, hey, if we take x times y and we get the same thing every time, that's because it's inverse. Now, if you're looking at that and you're saying, but that's the opposite of what we just did for 1 and 2. We said inverse is always division, and direct is always multiplication. Remember, this is the step before. The tables come before you use those models. So let's check and see. Take a look at number 3. Anybody see a pattern up here that might be helpful? Carson, what'd you see? Okay, so really what you're saying is if you take y and you divide it by x, you're seeing a 2 every time. Okay, so which one of those up there said if we do division and we see the same thing every time, it's this type? This is direct, because again, this is the step before our formulas. So we just found k. K is 2, and we're going to write y equals 2x. Oh, I didn't put it in the right spot. Y equals 2x goes down here. Because it was which type of variation? It was direct. Fill in the blanks right. Take a look at number 4 and see if you can figure out a pattern from number 4. Remember, there's only 2 things to check. If we multiply them and get the same thing every time, or if we divide and get the same thing every time. Anybody find it? Multiplying. So if we take these two, x and y, and multiply them together, we get 56 each time, right? So which one is that, direct or inverse? That's inverse. And we just found k, so it's y equals 56 over x. Now, if you're doing these on the test on Thursday and you're like, did I get confused about which one is which? Well, then go back and use your formulas and make sure they work. If you take 2 times 7, do you get 14? If you take 2 times 10, do you get 20? If you take 2 times 14, do you get 28? Yes, you do. Connor. It is, and that's because, remember, whenever we do the graphing and the stuff from here on out, we're having it be y equals, and that's generally y. It's always y equals. Over here, we'd want to take 56 and divide it by -7. We'd get -8. 56 divided by -2, we'd get -28. So again, check them when you're done. You'll have time. The test is 1 page, front and back. Plenty of time to double check those. So that was all about 8.1. Direct variation, inverse variation, joint variation. And then we got to the part where we started talking about graphing. So number 5 says, what is the domain of this function? And this is where we started using this model. Right there. But actually, without even knowing that model, we should be able to tell them the domain of this function. There's one number that's out, right? What number's bad? 3 is out because it would make a 0 in the denominator, right there. And if it's a more complicated denominator on the test, remember you can always find it by just setting it equal to 0 and solving. Sometimes we'll have a denominator that says like 2x minus 1, 3x plus 5, and you can always set it equal to 0. And remember, this is the number it can't be because that would make it a 0 in the denominator. So x can't be 3. Now with that same model, we have this problem. And it says, write an equation for the translation of y equals 2 over x with the given asymptotes. And our asymptotes here are going to be x equals -7 and y equals 3. First off, where does the 2 go? That's A, exactly. It's saying put that 2 on the top. Now, what had to be down here in the denominator for us to say that x equals -7 was a vertical asymptote? X plus 7. And you wouldn't need to put the parentheses. In fact, I don't want to confuse anybody. When we do the graphing later, we will. Where do we put the y equals 3? Yeah, in the back. Because this is that special model. Y equals a over x minus h, where h is the vertical asymptote and k is the horizontal asymptote. So if you're thinking you're going to forget, you can put VA down here, pardon me, and HA up there. So far, so good? All right, so definitely this was getting into section 8.2. And then for these, we're not going to go through and do the full graph. We're going to tell them if there's holes, where are the holes, where are the horizontal and vertical asymptotes of these functions. So let's take a look at 7. Is 7 going to have any holes? How do we know? Yeah, nothing's going to cancel, so none. Don't leave it blank. Leaving it blank says, I don't know. I don't know if there's holes or not. I don't have a clue. So put none in there. Vertical asymptote, where's that going to be? Yes, because 4 minus 4 is 0, and it's x equals 4. Don't forget to put x equals. It's an equation for a line, so it has to have x equals. Horizontal asymptote, that's yesterday's stuff. That's about degree. If the degree of the top is less than the degree of the bottom, we put y equals 0. If the degree of the top equals the degree of the bottom, then what do? We do the funky fraction. Oh, there's no numbers in front. What are those numbers then? And what's 1 over 1? And we've got it. Number 8. Hard to tell what's going on because it's not factored yet. So we have to factor this first. Anybody see a common monomial term we could take out of 4x squared minus 8x? And? Good, let's take them both. Let's take a 4 and an x. Now remember, if you're worried you didn't take enough or you took too much, multiply that back together and make sure you get 4x squared minus 8x. If you don't, then you did something wrong. And I don't like that bottom one. It's turned around backwards. Anybody remember how we can turn that around? Exactly. Yeah. Multiply or divide by a -1, and we can flip that around. Now we had to do that so we can answer these questions correctly. Does this have any holes? It sure does. And what number would make that a 0 in that hole? All right, so here's our job. Not only are we going to put 2, we're going to figure out 2 what for our hole. So to do that, we have to actually cancel out the x minus 2's and get the new formula if it was canceled, and then use that new formula. So if you put 2 into 4x minus 1, what would you get? That's where it's going to be. That's where the hole is. Vertical asymptotes. None? 2's a hole. Yeah, there's nothing else down there, so we have to put none. We already used that x minus 2 as a hole, because it is a hole. Horizontal asymptotes, that's all about degree. So this one is a degree 2. This one is a degree 1. Even though it's in the wrong order, it's still degree 1. So let's see, it was if the degree of the top is less than the degree of the bottom, it's y equals 0. That's not that one. If they're equal, do the funky fraction. That's not that one. If the top is greater than the bottom, what do we put? None. We don't get one. That was that part we talked about that without you guys knowing calculus, we just have to kind of memorize the horizontal asymptotes. So now we're definitely into section 8.3. Number 9, is this one going to have any holes? Where? Careful. People said 1. You're super close. Good, -1. Because these two would cancel out, and that's the zeros. So now let's actually do the canceling. And that would make it 1 over x minus 3. So put the -1 in there and tell me what little fraction you get. -1/4. That's where the hole is going to be. Vertical asymptotes. X equals what? X equals 3, because we did have something down here that wasn't going to cancel. If it doesn't cancel, then it's a vertical asymptote. Now, for horizontal asymptote, this one's going to drive some of you bonkers. And if that's the case, then actually do the FOIL down here, so you can figure out the degree. This is degree 1. This is degree 2. If the degree of the top is less than the degree of the bottom, we write y equals 0. And again, you have to have y equals. So vertical asymptotes are always x equals, and horizontal asymptotes are always y equals. All right, so that was a really good set of find holes, find vertical asymptotes, find horizontal asymptotes. Anybody have a question on that section, how we were getting some of that? Well, now we have to do that all and graph. So take a look at 10. Where should we start? We better factor that, right? Yeah, we got to see what are all these zeros we need to find. All right, there's no greatest common monomial factor. It's not a perfect square trinomial, so we go right away to good old-fashioned factoring. Do we know two numbers that multiply to -3 and add to -2? -3 and +1. On the bottom, there's no greatest common monomial factor. It is not a perfect square trinomial, so we need two numbers that multiply to -6 and add to -1. I heard -3 and +2. Everybody agree? Okay. Does this have a hole, and if so, where? 3 something. So let's find the something. If you actually canceled out the x minus 3's, it would say x plus 1 over x plus 2. So go ahead and put the 3 in there. And it's okay if it comes out a fraction. 4/5. Now, before we do anything else, we're going to put that hole on this graph. Because if we don't do it now, we're going to forget to put it on there later. So 1, 2, 3, and about there we put a donut hole. There's a hole in that graph at 3/4. Vertical asymptote. Did we have anything in the denominator that did not cancel? And what's the 0 for it? All right, let's get that graphed on there. X equals -2. Horizontal asymptote. Without me prompting, can you tell me what the horizontal asymptote is? Good. Somebody said 1. The degrees are equal. Do the funky fraction. Let's get that one on here. Trying to keep that up there far enough so we can still see what the original equation was. Because the next thing we're going to do is we're going to pop this in the calculator. So let me get my work off of here so that we can definitely make sure we put parentheses around the numerator and the denominator and get this into our graphing calculator so we can steal some points from the table. Parentheses, x squared minus 2x minus 3. Parentheses divided by parentheses, x squared minus x minus 6. Little zoom 6 so we can get a quick look at it. Well, that makes sense with what we have up there, that we'd have those two branches. Here's what you're going to notice. Do you see a hole up there in the graphing calculator? Because the graphing calculator doesn't know any better. The graphing calculators are made to try to attach everything. So until we get to the table feature, we're not going to see whether or not we're right or not about that hole at 3. So second, table. We need to steal some numbers to the left of -2, like -3 and -4. So let's get those. -3 is 2. That'll be nice for graphing purposes. -4 is 1.5. That's not bad. 1.5. So -3, 2, and -4, 1.5, and that is all we need. Now, I'm going to warn you. If you get this far and you give me this, because this has happened before, people do that, you're not getting full points for that. That says you don't understand what an asymptote is. Asymptotes are things that we're supposed to get closer and closer to, but never cross. So you've got plenty of time on Thursday to take this test. Do a good job. If you want some more points to graph on there, well, put some more points on there. That's perfectly fine. But you at least need 2 for that branch. All right, let's go to the other side. On the other side of -2, we've got -1. Could definitely use 0 and 1. And that might be enough because we know where the hole is supposed to be at. So let's go ahead and get some numbers. -1 is 0. 0 is 0.5 or 1/2. And 1 is, well, 2/3, but you could put, 0.7 if you want to. But here's the big deal. I want to make sure that at 3, when we said there was a hole, there's actually a hole. How does that tell me there's a hole? If it says error, only 2 things can happen at that number. Either it was a vertical asymptote or it was a hole. Well, it wasn't a vertical asymptote, so it has to be a hole. I'd probably be tempted to put 2 0.75 on this graph as well, just to make sure I've got a nice graph of everything that's happening. So -1, 0, 0, 1/2, 1.7, and 2.75, and then I draw my branches in, and I make sure I leave that hole in there, and then it's really obvious that there's a hole. Gonna do okay on this one? Remember, those error messages are good. They mean that's where vertical asymptotes and that's where holes are at. So our vertical asymptote is right because we see a -2 up there and there's an error. And we said that's where there's a vertical asymptote. Now, 11 is that different form. Oh, I'm not going to be able to fit that without scrolling up a little bit more. So with that form, do we get holes? No holes with that form. So we're going to write none. But it's super easy to find the vertical asymptotes and the horizontal asymptotes. Where's the vertical asymptote? 2. Because 2 minus 2 is 0. Where's the horizontal asymptote? Y equals 1. And we could go to domain and range right now and write x can't be 2 and y can't be 1. Because those are our asymptotes. And that's where we start our graphing. We're going to put our vertical asymptote at x equals 2. and our horizontal asymptote at y equals 1. Now, we can use a graphing calculator to graph this one. I don't recommend it because it's actually harder to put in than number 10 would be. And that's because you have to have a set of parentheses for the denominator, a set of parentheses for the fraction, and then you have to remember to put the plus 1 in the back. This one is easier if we just say, I need a couple of numbers to the left of 2. So what numbers on the number line are just to the left of 2? Yes, they're super easy numbers to work with, so you can put those in. And then we need a couple of numbers just to the right of 2. So what would be just to the right? 3 and 4. And we can do those in our head. We don't necessarily have to have a calculator to do those. I suppose you could check it with the graphing calculator if you wanted to. But we put a 1 in here, and 1 minus 2 is negative 1. 3 divided by negative 1 is negative 3. Negative 3 plus 1 is negative 2. Put a 0 in there. 0 minus 2, that's going to give us negative 3 halves, which is negative 1 1/2. Negative 1 1/2 plus 1 is negative 1/2. So 1, negative 2, and 0, negative 1/2. And there's our first branch. Make sure you put arrows on them because we have to show we understand they go on forever. Then we'll put a 3 in here. 3 minus 2 is 1. 3 divided by 1 is 3, and 3 plus 1 is 4. And we'll put a 4 in. 4 minus 2 is 2. 3 divided by 2 is 1 1/2. 1 1/2 plus 1 is 2 1/2. So 3, 4. And 4, 2 1/2. And always double check. Make sure your branches don't cross those asymptotes. And we've got it. Okay, questions about any of these 11 problems? Something you want me to go back to and explain a little bit more? Let's just say you absolutely wanted to check that last one because you'll have time tomorrow. Again, you're going to punch it in as parentheses, 3 divided by parentheses, x minus 2, parentheses, parentheses, plus 1, zoom 6. And there it is. So that's the practice test. I apologize, I got to answer the phone. It's probably somebody that had a pass. We'll see. Good morning, Mrs. Cedarholm. Okay, we just finished our practice test. She'll be on her way. Yep, bye-bye. Melissa, that's for you. So, no new homework tonight. You've got to catch up. Way too many of you are looking like you're going to end up on the summer school list. I don't want that. You don't want that. So, go ahead and make sure you get all your homework caught up tonight.